FDM. And you know what? Everybody knows what it is. So let's just start.
And if you don't know what that is, you can listen to today's Expo. Hello everyone, my name is Štěpánka Juránková and welcome to the podcast called Expo. We will talk about 3D technologies, today about technology FDM with Ján Galko. Welcome.
Thank you. Hello. Good to be here.
Everyone probably heard of FDM technology since it's the most popular one, but if not, let's start with the historic lesson again.
So again, some people might have heard this story, some may not. FDM or FFF actually starts in a garage, as it happens, as it does with these technologies. The name connected to it is actually Scott Crump, and he's considered a father of 3D printing. He is the one who started Stratasys, the company we or MK worked with for almost 30 years now, or more than 30 years actually. So how it started. He was actually making a toy for his daughter, Frog, if memory serves, and he was doing it with a glue gun, or what we consider a glue gun today. And he was doing it again layer by layer. And because he worked with plotters at the time, he realized again, the computer can be doing this, and some mechanism can be doing this instead of me. And so he conceptualized what will later become FDM or FFF technology. FDM is actually the same thing as FFF, but it's trademarked by Stratasys. It's the term Scott invented for this technology and had it trademarked. So the difference between patent and the trademark is that trademark will never expire while patent will. So he did this in his garage, and he saw the potential for that. He filed the application for patent, which was granted some time after that. By the way, it's the last one of the known technologies. You have first was SLA, then SLS, which would be powder bed, and the last one is the FDM. It's a 1989, I think. So he filed a patent, he got the patent, and he started the company Stratasys, which we all know very well.
So as you mentioned, this man used glue gun and made layer by layer a frog.
Mm-hmm.
So FDM actually works quite similarly to that. Can you describe that closely?
Sure. So instead of glue gun, you have a device called extruder. Essentially, it's more specifically designed glue gun. It's something that will have a heater on, or heating element, some form of heating on, and you push plastic wire through it while it's melted, and then it pushes through the other end, and the object is created. And this can be of different size, therefore you can create more precise objects, or more smoother objects, because your smoothness of your part will depend on layer height. And obviously this extruder, you can have one or two, or even quite possibly more, and it's mounted on the XYZ rail typically. Today you have models where you have like Delta 3D printer or something like that, where you have 3 arms essentially holding this extruder and moving in different way, because the classical one is XYZ and it's moving on those axes. This is moving a bit differently. But the principle is still the same. Like you extrude plastic through the extruder and you make layers with it. And that's operation of FDM. Of course, the materials have advanced quite rapidly in the last few years, because the patents expired, and therefore this technology became more available. And let's say people like Prusa or some Creality or anyone else in the world can use those patents and build their own machine cheaply, let's say more effectively if you want. And so that became a boom with these technologies, and they're quite popular. Like 95% of the people, maybe even more people, will imagine FDM printer when you mention 3D printing. So, and you have that in pop culture. I think the one of those cheap. I think Prusa is in Avengers, first Avengers, in one scene. So it's quite popular, and it's getting more popular as well.
And it's probably the 3D printer that people who have a 3D printer at home own. It's probably
Most
that
of
one.
them, yes.
Does this technology require some post-processing steps?
Of course, every 3D printing technology does, some more, some less, but FDM depends on what type of FDM. Like if you have only one extruder and you're only printing one material, as you printing layers, some angles, let's say, or some geometries need to be supported. And because you only have one extruder, this support will be of the same material. It can be slightly different designs, the walls can be a little bit thinner, but it will be same material. And you make a structure of the same material, and then you have to remove it, of course. So this will be, you need to mechanically pull it from your print. Then you can use a sandpaper, or you can smooth it with chemicals as well to make it to, let's say, clear that seams, or that because you will have marks, leftovers from the support or something. So you can use different types of post processing to negate this, to hide this essentially. Or if you have like two extruders there, you can load one with support material that will be dissolvable in water, like PVA is popular in the last couple of years. PVA is cheap and available, and it works, but it has the problem, it's essentially paper glue on in a form of wire. So what happens there, if you expose PVA to air moisture for prolonged time, it loses its quality and it's harder to print. So people who worked with PVA know that it can work, but it needs to be fresh. Or, as I said, these materials are constantly developed. You can use other dissolvable materials, like Stratasys has their own form of support materials, usually marked SR. And what that does, there needs to be a solution to dissolve this specific solution. And you simply submerge it into this solution, leave it in the process chamber, which essentially is a water tank with circulation and heating, and you leave that for a couple of hours or a couple of days, depends on the size of your print and amount of the support material that you need to remove. You leave it there, you come back pull out the essentially finished model, and you can work with it. Like, you can do what you need to do. And you have the finished product.
And is it true that you can create anything and everything with this technology, or what are the possibilities of it?
Okay, I would specify this a little bit differently. You can create anything, or you can print anything, but not every model. And why I'm saying this, it quite often happens to us that people from vacuum casting or from other or CNC machining, they have model for CNC machining or for vacuum casting, and they will come to us and ask us to 3D print it on FDM, and like, can you do this cheaply? And the problem is, I can, but those models don't have to work that well, because they will have when you print, you need to know what that model will do, and how you orient it and how you print it matters, because in FDM, in Z-axis, usually where the layer meets layer, that part is quite weakened compared to rest of the material. Like, you can have, I think in some cases, you can have half the strength you would have on XY axis. So in layer you would have certain strength, and in Z you would have half that strength. I actually had at some point, at the very beginning, I've tried to do something like pipe with a thin neck, and because I wanted pretty, I printed it in such a way that it was the neck was in Z-axis, and the wall was actually so thin that the print broke on that neck by itself. I didn't do anything. I put any pressure, just moved it, and it broke. So you can have that if you are not careful and if design is not right.
Mm-hmm. And can you maybe compare the price and the possibilities of the smaller printers you have at home and the bigger ones used in industry?
Sure. This is something that I talk to customers about. Like, you can get cheap and relatively well-working 3D printers, FDM 3D printers now, like Prusa or Creality or some others have, like Bamboo Lab is currently very popular here, and they can get great quality, and they're open source, so you can play with materials, with colors, with everything. That's perfect for inventors or guys who like to tinker. So that's perfect for your home, and they are not expensive. Couple of 1,000 crowns, some of them are not even hundreds of dollars, like couple of maybe 100. I think I saw small FDM printer for like $100 or something like that. So it's cheap, and it's getting cheaper, and you can play with it, experiment with it, learn on it quite well. But then the technology was called rapid prototyping, and therefore Stratasys and professional 3D printers will still focus on that. So what Stratasys gives you, it costs few times more than those home 3D printers, but it gives you speed and stability and, let's say, certification of certain materials, which the home ones will not give you. So if you want to prototype and you want to have your design in your hands next day, and you want to be sure that it's not going to clog or whatever these little printers will do, then you use Stratasys. If you have business and your business needs to run smoothly and effectively, you use something like Stratasys. Like, it's more expensive, but it's more reliable in that sense.
Okay. Thank you for your answers, and see you next time.
See you next time.
Bye.
Bye. FDM. And you know what? Everybody asking knows what, what that is.
Mr. Historian, tell us the secret.
So it's not a secret. Everybody knows this. As we mentioned earlier, everybody knows what this is.
Stop using please.
No. You didn't say it's PG 5. It's PG 13. I can swear all I want. There can be blood, everything. It's whole thing. People gonna love it. They love Deadpool. They're gonna love this.
Do you seriously compare Deadpool to this?
No, this is better. More educational.
I think so.